Welcome to the Making of What Matters. Today, we're going to have a discussion about the topic that is on everybody's mind, AI. We're going to talk about AI, but we're also going to talk about how AI is embedded in products, how it's driving value for customers. And I'm really excited to be joined here today by Mark Kelly, who leads our global software engineering teams. Hi, Mark. Welcome to the Making of What Matters.
Hi, Zari. How are you?
I'm very well, thanks.
Good.
Excited to have you. So you lead, I want to give the audience a little bit of an intro to who you are and what you do at Eaton. So not only do you lead our global engineering software teams, but also our Center for Intelligent Power in Dublin. Can you tell me a little bit about kind of what your teams do at Eaton?
Yeah, sure. The Center for Intelligent Power is an organization that was set up actually a good couple of years ago to take advantage of, I guess, what the leadership team in Eaton seen at the time was the emergence of artificial intelligence and machine learning. And so the company made a very prescient decision to start investing in this, started thinking about how this will embed within our top technologies and services. So over the last number of years, we've built out that capability on behalf of the company. As you mentioned, we're based in Dublin. We're also based in the US, in a number of locations, and in Pune in India as well. So we're a global organization. And who we hire in the centre is generally people that work or have a background in artificial intelligence and machine learning. And our focus is primarily focused on how do we embed artificial intelligence into the products we make, the physical products, the software systems we make, and also use it to underpin the services we provide to our end customers. So very much focused on the commercial side of embedding artificial intelligence into products and products offerings.
And everything we're hearing about in the market today on artificial intelligence is about the power requirements that are going to be needed to fuel artificial intelligence, to fuel all of the data centers that are going to be needed, all of the GPUs and the chips that are coming up. Tell me a little bit about how the work that we're doing at Eaton is helping to support those increased requirements.
Yeah, the data center is probably fascinating. Obviously, we have a well-established large business. We're a well-respected player in that space. But one of the advantages that we've had is we've been sitting at the intersection nearly between the grid and the data center. And what we're seeing, obviously, you mentioned it, is a massive amount of demand. Again, depending on the numbers you believe, you're talking the size of the global data center demand will be the size of a large industrialized company or country such as Japan. That data centers worldwide will use the entire power requirements of a country, an industrialized country, an advanced industrialized country like Japan. A couple of things to think about in data centers, certainly where we're looking at it is, number one, that will mean the architectures we've had at the data center will need to be rethought. That we normally built our data center or power and power resilience for around this idea of protection or the idea of backup. Whereas power, much more around, rather than resilience, it will move to be a responsive type of capability within the data center, having to smooth out the spikes. Because the way in which artificial intelligence works, or training, and particularly inference, as that becomes more and more common, is it creates lots of spikes of power. And again, what the GPUs and what the computing equipment really likes is really smooth and consistent power. And that's where we're right at the sweet spot of that space, right? Helping to do power delivery, power conditioning, power management. And again, a change. If you think about how the data center was normally built, it was built to manage capacity. That we'll have enough capacity, and once we have capacity to meet the computing demand, we're okay. The data center rarely get downtime. But now what the data centers have to be able to do is adapt. And it's not just adapting power now in a data center. A data center previously was all just about power, but now you have huge amounts of heat as a consequence of that power, and cooling. And now what you have in the data center is not just managing power, but it's being able to understand what the compute need is, which is sometimes known as the workload. That can be training, GPT model, it can be training another form of a large language model, whatever the case it is, or other AIs. And really what it is the ability to understand that model and provide the right power at the right condition at the right time for those people. It's a very different application, a very different use case, and it's an evolution of the data center. And going further, if you think about a data center, not so long ago, 5 years ago, we used to think of data centers as cost centers. That's places we put the infrastructure. It's a cost center. It's the cost of doing business. Well, now they're revenue centers. And the ability to provide power, a responsive power, is now a cost. Is not a cost center, it's a profit center. So them efficiencies are translating, if you think of the cost of training some of these models, are translating into millions, if not hundreds of millions of dollars for training. So it's a fundamental transformation. And I think for a company like us, what's interesting, going beyond the data center, I think where the data center will lead, many industries will follow. If you think of like industrial or factories, if you think of things like utilities, because obviously data centers are at the moment a means of production. They're term is going on, an AI factory. They are effectively AI factories, and they are the digital, factories of today and of tomorrow. So it's absolutely the most exciting place to be working in. The challenges are enormous. The compute volumes increasingly going up. The power of GPUs and other forms of processing is going up, and the challenges are becoming more complex. And that's where I believe AI will play an enormous part. And it couldn't be any more exciting.
And so that's how AI is impacting kind of an end market. And one of the things that you said that I think is really interesting, and we talk a lot about it at Eaton, is the work that we're doing to support AI in data centers is going to bleed into other markets, right? Industrial, into buildings, and it's going to affect the power requirements in those applications as well. So how do we start to think about the impact that AI is having on how we control the applications, the physical systems, the hardware that's in those different applications?
Yeah. What artificial intelligence is really doing is giving us degrees of autonomy, or it's starting to make decisions without necessarily human intervention. And I think that will be the direction of travel will go over a period of time. I think we're still, as an industry, as a society, in the early days of how artificial intelligence will truly kind of become part of the fabric of everyday life. Already, you look at something like ChatGPT, it reached the numbers of subscribers in 1 month that it took, Netflix 5 years to take. So you're seeing this permeating society, permeating industry everywhere. What I think was ultimately, as we go along, you're going to see this become more and more autonomous. And what I mean by that is that decisions will be made at speeds that which really no human could be made. You can imagine maybe changing power delivery to, an industrial system, or maybe, shutting down, for example, in a grid, parts of the electrical grid at speeds, which means you're not traveling all the way back to the traditional kind of SCADA-based system, the supervisory systems. If you picture a movie, you'll often see, people in front of these panels, twisting knobs, dialing knobs. I think a huge amount of what you're going to see in the industries in which we serve is that's really going to be artificial intelligence doing that, and humans providing a degree of oversight, a degree of training of those models. So I think that we're seeing that already in the data center. I think we're seeing evidence of that in utilities. I think we're seeing that in industrial. I think we've already seen it in commercial buildings and institutional buildings. So it's already happening. And I think we, as a society, are getting more comfortable with AI. If you probably ask a student, are they comfortable with AI writing their papers? They're probably pretty comfortable with it by now. Or taking help, right?
Well, I know you and I are using it every day to help us be more efficient, right? To be more productive in our jobs, to, better plan vacations, all of the things that you can use it for today. And it really is starting to permeate kind of the way we do all things.
It is effectively, for most people, it is the assistant they probably dreamed of. And, leveraging it like that is fantastic. And then if you take those type of examples, if you think about in the industries we serve, where people rely on us to deliver safe, resilient power, right? We really do. We're at the epicenter of so many pieces of critical infrastructure. Well, think of a technology that's sitting there that's never sleeping, never needs to be fed, and can just constantly monitor. And being able to embed our service offering, I think it gives it even more cachet to what we do, and much greater power to the products we make and deliver and the software we sell. And I think we're seeing evidence of that. If you think of something like a project we're very proud of that was led out of the US around wildfire detection, you think of the devastation of something like that. It's almost hard to imagine. You can certainly empathize, but to live through that, and for us in our organization, our company, to be playing a part and to be able to mitigate something like wildfire with our technology we're working on across the US, that really kind of brings it home to me. It brings it home to me that there really is a difference. For example, the kind of technology we build in Eaton, the type of AI we're building, it's about saving lives, keeping homes and property safe, and it just it really has a real sense of mission. And I think that's where the more we can use AI to enable applications, services, software like that, look, in my view, there's no more noble kind of work to be doing as well as technically challenging. It's incredibly rewarding. And I think we're going to see plenty more of that across, our applications. Our product teams are, very keen, very eager. I think one thing we do in Eaton very well, we also have a degree of healthy skepticism to make sure that we're putting it everywhere and saying, oh yeah, well, we're going to go crazy with this. We're very deliberate, very thoughtful. That's the types of products we make and the type of company we are. And we're seeing that in our AI deployments. But the interest and demand and the kind of applications our domain experts are coming up with are fantastic. And I think we've a long line of exciting products and technologies to come.
I want to talk a little bit more about the High-Z or the wildfire mitigation solution. Tell me a little bit about how AI is an integral part of detecting what's happening on the lines that can help to mitigate wildfire risk.
Yeah. So one of the things that this company is absolutely world-class in nearly every product we make is we really understand the electrical waveform. We understand how to break it. We understand to interpret it. And we really understand how to manipulate that waveform to keep people safe. At the heart of what the high impedance line fault technology is our ability to acquire those electrical signals on effectively on lines, right? Lines that run up and down the highways and byways of the US, and to constantly monitor those electrical waveforms and look for certain types of disturbances. Now, the thing that the air waveform technology does is the speed at which it can detect. For example, imagine it's actually a storm brewing out behind me. You wouldn't realize it. But if you can imagine very, very high winds and it breaks an electrical wire, and that electrical wire falls on, vegetation, and you imagine you're in like Northern California or Oregon over a dry summer, it's very, very dry. And that impedance means the line is down on the ground and it's generating heat at both sides. Time matters. Accuracy matters. Our secret sauce is how we're able to detect and then secure the line. In other words, break the circuit. And we do that like instantaneously. That's at the heart of what that solution does. So we're acquiring that waveform signal in really, really fast times. And the AI is making decisions in milliseconds. It understands what it's seeing. It's understanding the phenomena. It's looking for certain kind of features, patterns within that electrical waveform. And it says, oh, I know what this is. This is, I'm a down line on, brush or hay or whatever the case of it is. And it can actually then send them signals back to basically break the circuit, stop the heat, stop the wildfire.
Mm-hmm. I mean, it's so exciting to see what AI is enabling us to do in traditional hardware that we've had today, what we can add to it to make it be able to solve some of these problems that have been really hard problems to solve in the past.
Yeah. Examples of being able to, we have embedded our technology that we're actually able to embed it in our equipment that we can look for, determine connected motors and their health to see, we can actually not only detect faults within the motors, we can detect the type of fault within the motors to a high degree of accuracy. And one of the things that we've been doing in our company has been leveraging the size and scale of Eaton to actually test these in our own factories. So before we even brought them to customers, one of the things that we've been doing is use them in our own factories to find faults. We've had, again, the great thing is enough skepticism to say, hey, let's look at that. Let's really deep dive in that. And we've been using our own effectively scale, our Eaton wide scale, to basically, effectively accelerate and test and validate these technologies before we even put them in front of customers' hands. It's been quite remarkable.
Drinking our own champagne, right?
Drinking our own champagne, absolutely. Mm-hmm. And as importantly, listening to the experts that run our factories, right, and using them as a voice of customer, and that informing us about our product development, from how we install these things to how the best to run them, how they want to consume information. So it's sometimes not just about the algorithm. It's about the user experience around it and making sure that what we're building is products that are easy to use, easy to interpret, and will run and be reliable in the environments in which they need to be run, which in a company like us, we are often deployed in the most harsh and hazardous environments you can imagine.
Right.
These things need to be tough.
And it needs to solve real problems, right? And who better to tell us what those problems are than the people who are running the plants, the people who are running the machinery, right? The people who are working every day to make our products as reliable and efficient as they can be.
Yeah, and I think that's something we take a bit of pride in as a company. We really focused on making sure when we think about these products, we're not a hammer a hammer looking for a nail. That we are actually trying to basically solve problems that have value and utility and have a strong value proposition to our customers, and then work with our customers to solve those problems. For example, we've done that with the motor health you mentioned. We actually had done it as well with the high impedance line fault, working with customers. We're doing the very same thing with some of our data center partners as we're looking and kind of co-developing, co-creating with them to understand what they're living in their environments, because sometimes they will have unique, whatever environmental conditions, unique workload, whatever the case of it is. So by us going and partnering with them, what we're really doing is making sure we have technology that works for them, and it isn't sort of generalizable, might work kind of technology. It really is grounded in working and co-creating with our stakeholders, with our customers.
So the other thing that we're starting to hear a lot more about when it comes back to AI is, so as we think about the power requirements, and we think a lot about energy efficiency, right? And where's all this power going to come from? And how can we make sure that we're thinking sustainably about power? And that lends itself to topics that we've been talking about for a long time, about distributed energy resources, about the energy transition. How do we think AI, and maybe even more so AI embedded in hardware, AI as an important component to software, is going to help us to enable kind of more sustainable power for the long term?
Wow, yeah. That's a big question, and I'll try my best to try and answer it. Right, there is certain hard limits, if you want to put it that way. And again, I might use the data center as an example, right? Because it's where you're seeing this, right? Where you're actually seeing these hard limits, these kind of system boundaries really starting to rub up against each other. So you think you have grid, and you've carbon ceilings, right? So you probably have, for example, in certain parts of the world, you're starting to see things like site-wide, caps. And you're actually even things in like the electrical grid, you're starting to see node congestion. And that's real, right? You're also having to look at, as you said, the sustainability, the kind of CO2 costs, right? In other words, a carbon relationship between the cost of compute. And then if you take in renewables, which I think are becoming part of it, and on-site generation is becoming part of that story as well. Some of those renewables can be a little bit variable, right? The sun doesn't always shine, the wind doesn't always blow, right? These bring in disturbances in a way to the guaranteed supply. So you have to, first of all, manage those factors. Then, by the way, there's also even permitting, right? You install big, huge data centers that are growing from hundreds of millions to billions to billions on billions of dollars. So the idea of time to power and interconnecting these devices into different types of geographies and different types of domains, that's another challenge. And then, of course, as you mentioned, right, waste and heat sinks. In some parts of the world, you're seeing things like district heating, where the heat from the data center is used to heat people's homes. And all of this, right, is at work trying to figure out then standardization, because one of the things we want to do is drive higher voltage. And I think direct current will be a big player within that as well. Now, if you think of even just starting to manage all of these pieces, right? So a shift within the data center from the traditional AC power to higher voltage DC, right? That enables a degree of efficiency. It also enables a bit of that kind of responsiveness or resilience or elasticity in the headroom. In other words, the amount of capacity you have. You then have, right, managing power, heating, cooling, and making sure that the power, heating, and cooling is you're trading them off against what you need for compute, right? Because that's ultimately what's critical. So the control stack, the software, right? These kind of like how we're going to embed software in our products for that to be responsive for different levels, right? So down at the kind of rack level, for example, you're going to have intelligence embedded within the rack. You're probably going to have intelligence based on, even in subparts or whatever way it's segmented of the data center. And then you'll have a degree of control of the data center and maybe then even fleets of your data centers, part of your unique asset base. So I think another big area, so that's going to be a huge area, a level of control. An area that I know we're focused on in Eaton as well around modularity. So the idea of being able to do things like isolation, this concept around blast radius, right? But also being able to do pod level isolation. So you have little overlap. Again, building responsiveness, but also resiliency in. All of these things will require effectively, if you think about DC, it's a fundamental transformation of power. If you think about the hard limits or the constraints, they're pretty hard limits and constraints we're now dealing with. And then the outcomes we want to be able to do is we want to be able to continue to deliver compute, which is, just a bog standard way of saying I need to be able to train or do inference. So when we ask ChatGPT the question, it's doing inference.
It answers.
It answers, right? So it answers to us. It's not sitting there. You're maybe doing an exam or something or whatever it is.
We don't. Let's just be clear. We don't condone cheating and using ChatGPT on your exams.
Not at all. or whatever it is. You're waiting for a recipe. It could be whatever it is. Right. And then you think of these, going back to that kind of thesis, you say that these are no longer just cost centers. That downtime efficiency in these is actually business outcome. It's direct profitability. Like it's a fundamental, in my view, reimagining with a range of different technologies. So then you have like power electronics, more and more that's entering into the equation. And then it's going to be control and different levels of control inside the data center. Because again, most data centers, if you ever walk them, yeah, there's people working around them, but they generally are, racks and racks and lines of machines that are just sitting there doing their thing, connect. So for me, I think that's a huge technological challenge that I think we're going to see a huge amount of innovation from. That innovation will be a significant part of solving the sustainability, the scale, and the cost challenges around this. Whether you're an operator, whether you're a government, or you're a vested stakeholder, a data center operator, or a cloud vendor, like everyone, there's no putting this, I think, the genie back in the bottle.
Yeah.
Well, quite frankly, who is willing to give away the comforts we now enjoy and the way in which we work? I'm in Dublin talking to you. We've multiple people around the call here from different parts of America. We're talking here, and we're able to record this video. We're able to get good sound quality. That is all compute. That is all data centers. That is all where the means of production. I often think about, the Industrial Revolution of maybe whatever it was 200 years ago. They were steam factories. The factory means of production, the means of most production today are, data centers connected by, high performance fiber optic cable, backed and supported with efficient, safe power, keeping those machines up and humming.
What, Mark, are you most excited about when it comes to what's coming next in AI?
I think for me, the places we're looking at are most exciting at the moment, and I think I'll give you some examples. If you look at a large language model, it's absolutely brilliant. It's transformative, as we said. But there's a great example someone had seen, I think it was on LinkedIn, that they said, wire me a 3-pin plug. And there's various kind of like ways in which ChatGPT has, wired a 3-pin plug. Most of them will probably end in injury, or some may even end up in
Right.
right. So they're fantastic for maybe, a good recipe for a Saturday night, but maybe, for doing kind of the type of work that our company is world famous for, maybe isn't the greatest thing. So there's a few areas that I'm most excited about because I think we're well positioned in our organization to take advantage of that. One is what I would call this kind of physics-informed AI or physics-informed neural networks. I think that's a hugely important topic. It goes back to what I'd said around us codifying all of that deep domain expertise that sits across our entire company around electrical waveforms, around safe and efficient delivery of power. I think that is a very exciting area, and an area which we would have a very strong capability across our company with considering our domain experts. There's another area that I'd mention around neurosymbolic AI. And really what I mean about that is imagine you combine all of the brilliance and speed of a neural network, but it has common sense. It actually will check the neural network to check, well, hey, maybe make sure don't to turn off or power down a system in a particular sequence. And it will actually ensure a degree of safety or explainability. So the physics informed, because I think that's a huge part of what we are experts at in this company. Neurosymbolic AI. I think digital twins is very exciting, and the ability for us to be able to manage, distribute power in the virtual world, being able to model, predict what's going to happen in a building, in a factory, in a data center, in an AI factory. I think they're really exciting. And then, the challenge I'm most interested in is what you might call then the multi-physics optimization. And really that is, if you think about, say, a data center again, it's one thing driving more power, but with more power comes more heat. With more heat becomes more cooling. And with more compute requires all of the three of them. And how to adapt and program systems that can dynamically and adaptively control all of those effectively different objectives at the same time is an incredibly exciting area. So they're the things that really excite me, because I think that is a journey towards more and more what you might call autonomous power. And I think that's the direction of travel. I think that's incredibly exciting. And I think I'm incredibly lucky to be working in a company that's right in the epicenter of all of these kind of, generational changes happening all at once, because all these problems, as you described, they're all coming at us, and to be lucky enough to be able to work on a few of them is, a privileged position.
I'd love to be able to talk a little bit about digital twin technology. It's something I think we're starting to hear more about, this idea of being able to model what's happening in real life virtually. Can you talk a little bit about how that technology works and what the benefit of it is?
Yeah, it's a term that's been probably around a while, and in a way to think about it is the Internet of Things. When that was around, that was probably in some instances, right? Certainly, some of the hype of it was probably a hammer looking for a nail. But I would have always thought that digital twin technology was a technology enabled by the Internet of Things. And what I mean by that is, if you can imagine that we started to connect up devices, assemblies, switchgear, circuit protection, motors, relay starters, whatever the case it is, whatever equipment and whatever industry you're in, as we started to collect this data and send that data in real time, what we were able to do was get a picture of what was running in a factory 10,000 miles, 5,000 miles away, whatever the case of it was, that normally, you would have on the go, or you'd have to get someone to ring you and send that information. And what the digital twin technology really is built on that ability of called telemetry. These devices sending you a whole lot of information. And there's a couple of different types of digital twins. One is what we call an operational digital twin. You're pulling all that data in. And what you're able to do then with all that vast volumes of data, you're able to predict, am I running optimally? Is there ways in which I can optimize can I predict how much, power I'll need for the next 24 hours? And maybe then can I get can I go to the markets to get a better deal or whatever the case it is, or do arbitrage? So there's a sort of like operational digital twin. And you can imagine that as almost like, again, that never sleeping system that's constantly monitoring everything and is able to, make recommendations based on your history and based on what your business objectives are. There's another digital twin that I think is quite exciting as well. And it's sometimes, a design twin. And that enables you effectively pull all of your information to maybe design. And an example, you can do a digital twin that's like a product. We have digital twins of some of our smallest products in our company, but also digital twins of factories, of buildings. And as you can imagine, if you're able to pull all of that information, that operational data and then design data, what you can actually start to do is design and model effectively in the virtual space, something that you probably would have either having to prototype in the past or actually build a big, huge building and then run to optimize it. And the most amazing thing as well is you can run, because you're now in the compute domain or the digital domain, you can actually have, a limitless, I guess, but, many, many digital twins running on a design at any one point in time. And it's like the idea of all of a sudden, if you think about how you used to do a prototype, sometimes you design it manufactured, and then you'd get it back and you'd get some feedback on it, and that design cycle would go again. Digital twin technology enables you to take all of the information you're learning about that device in the field, all your design constraints or your design objectives. I want to make it lighter, I want to make it cheaper, I want to make it stronger, whatever the case of it is, and just instantaneously. And that is, a transformational leap forward in how we're able to design and prototype from an individual, component right up to buildings, right up to building. And that's where I think the excitement is around digital twin. We use them extensively, by the way, in the company in terms of helping us design and evolve our products and technologies. We've had some great success in that space. We're working then with, providers of other tools as well in their ecosystem around, for people that do design or architecture design or building models, to be able to make sure that what we have as our equipment is embedded within those ecosystems as well. So
we just announced, I think, a partnership with Autodesk on digital twin technology in support of how do we build more efficient energy management systems, right?
Brilliant example. And they're a world leader, of course. They're, as famous as they come in that space. So part of those ecosystem players enables us to ensure that, first of all, we both win from that, right? They have access of all of that Eaton equipment. That means that their drawings, their models are more accurate. And guess what we're doing? We're learning about integrating into those ecosystems as well, and making our products and technologies as seamless in that digital realm as possible. So incredibly exciting. I think, that's another important area that I think we'll continue to see more of. That if you think of a data center and you think of a lot of these complex, really hard problems, it really requires an ecosystem to win. It requires comfortable and being a real good partner within that ecosystem. That's something I'm very excited seeing, that like the company is very, very focused on being a good ecosystem partner, a good ecosystem player, and even excitingly being a leader within the ecosystem. People are looking to us to lead, and I think Eaton is up for the task. So that's pretty exciting too.
So there's a term that we're starting to hear a lot more, this idea of software defined. Is that just a marketing spin? I mean, I'm a marketer, so I know how it works, but tell me a little bit more about what that means and what we're talking about when we talk about software defined systems.
Okay. So it's probably more than a marketing term. I think it's just entering in probably the power industry, the energy industry now. But actually, there's a great corollary in the data center world. About 20 years ago, the biggest problem in a data center was not power. It was actually moving packets from computer to computer around networking. And one of the areas that started to emerge out, right, was this idea of, well, software-defined networking and being able to use general purpose computing technology rather than highly specialized hardware, which was often the case in the data center. And what that enabled us to do was to move certain network functions that were often very hardware specific, from the hardware domain to the software domain. And broadly speaking, that transition of moving from kind of specialized equipment to kind of general purpose compute, and the evolution or transfer of what were oftentimes like mechanical, electromechanical, mechatronic, electronic, digital, that kind of evolution, which, this company has actually lived its entire history. This is, it's a great, from start to finish. What it really describes is then that a lot of them technologies become software. So we've seen even some of our competition, right, release products that were once very much physical hardware products that are now completely software-defined products. I think we see more and more around of that. So software-defined power is really the same idea. What within the power management chain will go from being a very hardware or mechanical or electromechanical to a software domain? You mentioned control. I think that's a great example. If you think of things like semi-state or semi-state or semi-solid, or say, or wide band gap semiconductors, what you'll actually see there, right, is a huge amount of the control is actually software defined. I think we're seeing that in plenty of other examples. I think some of this will be driven by, again, the data center and just the need there to solve those problems. It really is the kind of nexus of where a lot of this is happening at the moment. And I do think that software defined power is more than a marketing term. It was well established within the networking field, and again, driven by data center demand at the time. So there's an interesting corollary there, maybe. And I think we will see the evolution in the industrial and power domains that will follow at maybe different rates. Because again, if you think of utilities and data centers and industrial, we really that's really, really mission critical equipment, right? A computer in a data center kind of falling over and maybe having a bit of a blurb is one thing, but a lot of the equipment we make. So I think it's on a slower trajectory, a slower path, but I think the direction of travel is inevitable.
Yeah. Very interesting. So that's all the time that we actually have today, but this was a great conversation, and I feel just a little bit smarter than I did before we started talking. So Mark, thank you so much for the time today. And for everybody watching, if you want to learn more about artificial intelligence, about software-defined power, you can visit us at eaton.com/digital.